3.7 is on implicit differentiation. So this is now that we've done a bunch of derivatives, basically of functions where you say f of x equals y or y equals f of x. Now we're going to look at derivatives of like a circle, x squared plus y squared equal to a constant, stuff like that, with a few assumptions. So this is what we look at. This is the method of differentiation. So the method of what's called of implicit differentiation. So a couple things. One, we're going to treat x and y as variables. Both of them are variables. So you're going to take those derivatives of each of them. And then two, it's the chain rule concept, because we're going to say that y is always a function of x. So we're going to make the assumption that y you can write, you could write explicitly, not implicitly, but explicitly as a function of x. And then you need to, on y, apply the chain rule. So I'll say, and apply the chain rule. For y. So you'll see, you'll do the derivative of y, and then you'll say times y prime, or dy dx. So for example, let's just do my simple example I just showed you. X squared plus y squared equal to 1. We could solve for y. So this is actually equivalent to saying y is equal to plus or minus, meaning you get a top half of the circle and a bottom half of the circle, the square root of, and it would be 1 minus x squared. A little too far on my radical there. But that's two different functions, and then to do that derivative, y prime, you'd have 1/2 times what's inside times the derivative of what's inside. It's not too bad, but it is more work. And there's going to be times you can't solve explicitly. So this is what we would say is implicit form, like a function. Y is implicit in there. This is explicit. Y is explicitly solved for. So instead, we can say you differentiate both sides. We can say d dx of x squared plus y squared equal to, and you must do both sides then, d dx of the constant. Of course, this constant's going to be 0, and then you're going to take the derivative and distribute to both of those. And so it would look like this: d dx x squared plus d dx y squared equal to, and this and that of, that's just 0. Let's just go ahead and do that. So now derivative of x squared is just 2x, but it's already a function of x, so you just leave it. And then plus derivative of y is 2y, and then you must use the chain rule, times, and we'll say y prime equal to 0. And then we can solve for y prime. So 2y times y prime is equal to negative 2x. So y prime is equal to negative x over y. So I reduced the 2, right? So you can reduce the 2. Now I didn't there's going to be times we want to maybe substitute in for y here, but otherwise you don't have to, as long as you know like an ordered pair. So essentially, if you know an ordered pair that's on the circle, then you can find the slope of the tangent line by just substituting into there. So that's the nice thing about it, the powerful thing about it. Okay, so remember, when you see y and you take its derivative, you then say times y prime, wherever you see it. Okay, let's look at another example. Okay, so find dy dx for y to the fourth plus 3y minus 4x cubed equal to 5x plus 1. So there's no like chain rule needed or anything like that. So you're just going to take the derivatives of each of the terms. But for this term and this term, what will you need to do? What will you need to do? You'll need to do a y prime after you take the derivative. These you don't have to. You just take its derivative, and since it's with respect to x, or I mean it is x, and we're taking a derivative with respect to x, you just leave it. So try it. This is a good one. I mean, usually these I just have you try right away. So try this one. And you say, and I'll write some more. You can just start taking derivatives, but I'll write it out this time again. d dx of y to the fourth. So it's this whole thing. And then you just go through and take its derivative. You don't have to distribute and show all that, those steps. d dx of 5x plus 1. So let's go ahead and take its derivative. So you get 4y cubed, and then what? Times y prime. Plus 3, and then what? Times y prime. Minus 12x squared, and that's it. You could think of it as every time you see that, you got to say dy, derivative of the function or the variable that you just did with respect to x. And then when you see x, it's dx dx. And so that's just, of course, 1. You could think of it like that if you want to. So let's continue. Equal to, so I'll erase this, but you could say it's 5 and then times dx dx, which is always 1. So you don't have to put it. But that's something that can help. And then 0, derivative of the constant 0. And then we still want to solve for y prime. Most of the time you're going to want to do that. Okay, so then solve for y prime. So we're going to add this on both sides and then factor out the y prime and then divide. Okay, so see if that makes sense. Okay, so you get y prime factored out, 4y cubed plus 3 equal to 5 plus 12x squared, y prime equal to 12x squared plus 5 over 4y cubed plus 3. Okay, let's see. Here's the next thing we may want to look at. So we'll use the same polynomial. We'll use the same one as this. And now we can maybe say find the slope at a point. So we already have its derivative then. So let's take a look at that. So this example, find the slope of the tangent line to the graph. Of y to the fourth plus 3y minus 4x cubed equal to 5x plus 1, same as above, of course, at the point P 1, negative 2. Now, you would have to know, like, you can't just pick any random point, right? I mean, you have to know that point is on the graph. It's given, so it's, you assume that it is. I mean, you could check it if you wanted to, but no need to check if they give it to you. So this is, your x and your y. And if you plug it in for x and y, here, and then negative 2, you should get a true statement. Okay, so we need slope of the tangent line. So we already have this form, and we just substitute that in. So y prime evaluated at that point is equal to 12 times x squared, which is 1 squared, plus 5 over 4 times negative 2 cubed plus 3. So you just work that out. You end up getting 17 over, and then that's 8 times, so negative 8 times 4 plus 3. It should be 29. I think that looks right. So then that's all they ask you, but what if they ask you to find the equation of the tangent line? Okay, so let's just call that A, and then how about I'll throw in a B as well. Find the equation of the tangent line. So we can use y is equal to mx plus b and solve for b, or y minus y1 equal to m times x minus x1. Either is fine. Lately, at least in my algebra classes, I've been using this one. I don't know why. It seems like we like it better, and then you just have to remember one thing, really. So let's just use that. So you put in negative 2 equal to negative 17/29 times 1 plus b, and then you just solve for b. So you get negative 2 plus 17/29. I'll let you work that out. It's negative 41/29. And so you get y equal to negative 17/29 x minus 41/29. Okay, a little crazy, but that's all right. That's just what happens sometimes with this stuff. Okay. Let's see what else I got. I have a number of these for you to do. So I think what I'll do now, because that's really the idea. I'll paste them up, and you go ahead and try them. Try not to look at the solution maybe, but I'm going to paste them all up because it's really just the same technique to take its derivative of all the rest of them. So I just need to find it. There's my derivatives. And we should be right here. So these are the other ones I wanted you to try. All of these, all the way down to here. So there's 3 more left. Try all those, see how you do on them. Okay. So write down the solution write down the question and then find y prime. This one I asked you to find y double prime. So once you find it, you do the derivative again and continue. So see if those make sense to you. Plenty to practice. This is another one of those we got to practice questions. Okay, then we'll be going on to the next section where we're going to basically treat x and y both as functions of t, like that. So in this case, when you do, you'll do d dt of like x of t, and then you just say like t prime, where you say the prime afterwards, dx dt or dy dt. So this will be equal to basically dx dt. Well, you got to do its derivative. So, so if you had something like this, let me erase that. So when you do that, you're basically going to do the derivative of x and then dx dt. So it ends up being the chain rule on it. So both x and y are functions of t. So you're going to do, it's going to look like that. And then you have to use the chain rule. So I'll have to do an example because it's kind of hard otherwise. So for example, if you had, let's try this one. So if you had x squared minus y cubed minus 2x plus 7y squared minus 2 equal to 0. When you treat x and y as function of t, then when you do d dt of the whole thing, and then this is d dt as well, so you say, oops, I'm going ahead and I probably shouldn't have, but whatever, d dt, that's 0. Then you say 2x, because you take its derivative, and then you say dx dt. Then you say minus 3y squared, and then dy dt. So each time you take the derivative, you say that afterwards, because each function is a function of t. And minus 2 dx dt, 14y dy dt, and then that's 0. So now you have each one of those as functions of t, and then these are called related rates. So you treat it as like a rate, and you're relating the rate between the x and the y. So related rates is what we're going to do next, and treating each function as a function of t, each variable as a function of t.